Okay, now that we have defined malignancies of connective tissue or mesenchymal tissue as being sarcomas, and we have defined malignancies of epithelial tissue as carcinomas, let's look at some of the common patterns of carcinomas. In the first pattern, called a squamous cell carcinoma, as you would guess, the malignancy arises from the squamous epithelium, or squamous mucosa, if you will. Here is a squamous mucosa. You can see there's a little bit of keratinization on the top. It tends to mature from the basal layer towards the superficial layer. You can also see similar looking tissue completely underneath the basement membrane. This is to show you that these invasive little nests have arisen from the surface epithelium, even though you may not see a direct connection, and that's why this is called squamous cell carcinoma. Squamous cell carcinomas arise from squamous epithelium, whether they are primary squamous epithelium or, in the case of the lung in many cases, metaplastic squamous epithelium. You could just see they look similar, but nevertheless this is malignant, it's invasive, it has perforated this basement membrane and is now in the connective tissue. And I just want to point out something, that if you look at these little concentric swirls of cells in many areas, especially here, but to a lesser extent here and here, these are called pearls, P-E-A-R-L-S. This means it is a very high or very good or very well degree of differentiation. Here's some more of those pearls, a little bit closer up. And the reason why I'm pointing this out is because when you see these pearls, you then have no doubt that this has arisen from squamous epithelium. And you would guess that these pearls are composed chiefly of keratin. And just as the surface epithelium matures from the basement membrane towards the surface in a squamous mucosa, you can see that there's same kind of a transition in these little infiltrating squamous nests as well. If you don't see pearls, but it still looks squamous, there may be tiny little cytoplasmic strands separating the area between cells. These are called intercellular bridges, and they correspond to tonofibrils or desmosomes, which are the structures that anchor squamous cells between each other. So if you see a tumor in which you could see these little spaces, like here and like here, you may not be able to see them too well, and there's tiny little crosshairs in those spaces, you know that this is a squamous cell carcinoma. It may not be as well differentiated as a squamous cell carcinoma that shows pearls, but nevertheless it is a feature which is unique to squamous cell carcinoma. Here's a carcinoma in which you can see glands or circular tubular structures. This is characteristic of all adenocarcinomas. So this is our second type of epithelial malignancy, adenocarcinoma. It could have arisen from any gland or any tissue that is normally glandular. This happens to be a case of colon adenocarcinoma arising in ulcerative colitis. But if I showed it to my pathology friends and told them it was from the pancreas or a salivary gland or even a lung, they would certainly believe me, because all adenocarcinomas, although they could have a wide variety of adjectives and appearances, they basically all look like these little haphazard glands. Here is a third pattern of carcinoma. On the one hand, you could see areas like this and this and this and this, these little round cells. You know these are just inflammatory cells. There's lymphocytes. But look at these little sheets of large cells here, like here, and all throughout here, and extending down here. This is a malignancy that looks epithelial, so it is called carcinoma, and it doesn't form glands clearly, so we can't call it adenocarcinoma. And it really has no features of squamous cell carcinoma either. So we can call this just an undifferentiated carcinoma. In the lung, it may be called a large cell carcinoma, which is a good name for it. But we have now seen the three major patterns of carcinoma growth, which are squamous features, glands, and undifferentiated sheets of epithelial tissue. Let's talk about some more classifications of malignant tumors besides carcinoma and sarcoma. Sometimes we have tumors which have a mixed differentiation. For example, a pleomorphic adenoma of the salivary gland has both connective tissue as well as epithelial components. It's a benign tumor, that's why it's called pleomorphic adenoma. If it was some type of malignancy, you know we would see the word adenocarcinoma in there. A malignancy called a carcinosarcoma, seen in various places, would have both malignant features of epithelium, the carcinoma part, as well as malignant features of connective tissue, or the sarcoma part. A teratoma, whether it's benign or malignant, is composed of cells from more than one germ layer. And technically, if you have totipotential cells which have the ability to give rise to all three embryonic germ layers, these could very easily form teratomas. But in order to diagnose a teratoma, you have to see features of more than one germ cell layer. In other words, connective tissue and epithelium. Sometimes the word hamartoma is used, and hamartoma in no way is a true neoplasm. Hematomas generally refer to disorganized masses of tissue whose cell types are normally indigenous to the site of the lesion. A word that is very rarely used, but it's still in the books, is choriostoma. And all that is ectopic focus of normal tissue. Another name for choriostoma would be heterotopia. The most common example of this would be aberrant pancreas, scattered around the stomach or intestine or mesentery. And remember, we're going to use some words now which all imply malignancies, but they're not, they don't have the word carcinoma or sarcoma in them. And there's several examples of this. Here's the four most common. A hepatoma doesn't have the word sarc or carso in it, but it's still malignant. There is no such thing as a benign hepatoma. Similarly, there is no such thing as a benign melanoma. All melanomas are malignant. The word malignant melanoma is redundant, just like the word malignant lymphoma, although it's used often, is also redundant. All lymphomas are malignant. Seminomas are all malignant as well, but they don't have the word carso or sarc in them. So just keep these little exceptions in mind as long as we want to define nomenclature in the very, very best way we can. Here's a tumor of the ovary. If you can see closely, there are little hairs in it. You can also see a little tooth. So hair is an epithelial derived structure. Tooth is generally connective tissue. This is a teratoma. This happens to be a benign cystic teratoma of the ovary. Most teratomas of the ovary are benign. Most teratomas of the testicle are malignant. But the point I want to make is that we can call this a teratoma because it's giving rise to structures from more than one germ cell layer. I have about 10 seconds left on here, so we'll finish up on some more teratomas in the next clip, and I thank you very much.